This question asks, if the price of a sandwich changes from $3 to $8, what is the change in the number of sandwiches he buys each week? Well, it told us that he has a budget of $80 per week, so we know this budget constraint, which says the amount that he can spend, $80, is equal to the price of sandwiches times the quantity of sandwiches plus the price of beers times the quantity of beers. It also gave us his utility function, which was U equals 0.7 times the ln of the amount of beers he drinks, or QB, plus 0.4 times the ln of the number of sandwiches he eats, or QS. It tells us in the question that the price of beers is $7, and we know that the price of sandwiches changes, so first let's look at when the sandwiches cost $3, and let's see how many sandwiches he'll eat when they cost $3. To maximize utility, we need to remember this relationship. This is known as the optimization condition, and you'll often hear it referred to as equal bang for buck. It says the margin utility of beers divided by the price of beers must be set equal to the margin utility of sandwiches divided by the price of sandwiches in order for us to be maximizing utility. So first we need to solve for the margin utility of both beer and sandwiches. Well, that's just the derivative of the utility function with respect to each variable. So the margin utility of beers is 0.7 divided by QB. The margin utility of sandwiches is 0.4 divided by QS. Now QB and QS, those are both denominators that are in the numerator, so they belong in the denominator, and we can move them there. We're ready to cross multiply. 7 QB times 0.4 gives us 2.8 QB. 0.7 times 3 QS gives us 2.1 QS. Now we need to solve one of these variables in terms of the other one. And which one do we do? Well, since it's asking us about our consumption of sandwiches, we need to solve QB in terms of QS. So we do that, we divide 2.1 by 2.8, and we find that QB is equal to 0.75 QS. Going back to our budget constraint now, we want to plug in what we just found for QB into our budget constraint. So now we just have QS. So we can multiply the 0.75 QS by 7 and combine like terms to get 80 is equal to 8.25 QS. Divide 80 by 8.25, and we see that the quantity of sandwiches we eat when they cost $3 is 9.696. Well, how many sandwiches will we buy if sandwiches cost $8? Notice that the price of sandwiches is the only thing that is changing. So the margin utilities of each didn't change because the utility function didn't change. The price of beer didn't change. So going back to our optimization condition, we see that we just want to switch 3 with 8 because now the price of sandwiches is $8 instead of $3. Again, we want those QB and QS's to be in the denominator, so we suck those down, we cross multiply, and again we want to solve for QB in terms of QS, so we divide 5.6 by 0.28, and we see that QB is equal to 2 QS. Again, visiting our budget constraint and substituting what we just found for QB into it, we can have just QS, and we do some algebra. Dividing 80 by 22, we see that the amount of sandwiches we buy when the price is $8 is 3.636. Well, this question was asking us about the change in sandwiches, and we know that it's just going to be the difference in QS1 and QS2. But to find out what the sign is on that difference, is it a negative number, is it a negative change or a positive change, we don't really want to remember any order here, we just want to think about it. The price of sandwiches has gone up. So we know the change in sandwiches is 6.06, and it's because the price went up, we know that it's a negative 6.06, right? Because the price has gone up on something, we're going to consume less of it. So we want to reason out our change like this, using our basic knowledge of price and quantity and the relationship which is inverse between price and quantity. So because the price of sandwiches went up, our quantity should have decreased, and therefore we should have a negative 6.06 change.